right, so this is your review video for activities 10 and 11, Unit 2. So just going to go through, as always, just about one of each type so that we cover at least all of the different topics that you should definitely know in order to be prepared for your embedded assessment and for your quiz. So first one that most people have had questions on is number 2, where they give you the focus at -1, -9/4. They give you the directrix at y equals -7/4, and they give you a point, -2, -3, and tell you to show that that point is the same distance from the focus as the directrix. So remember that that's true for every point on the parabola, including the vertex. Every point that you pick on the parabola should be the same distance from the focus as it is from the directrix. So when I do this, the best way to do this is to draw it. Draw yourself a picture so you can see. So these are all relatively small numbers, so I would make my sketch pretty big because I only need to go over to -2 and down to -3. So -2, -3, here's the point in question. Then the focus is at -1, -9/4. Now, -9/4, if you write that as a mixed fraction, is -2 and 1/4. So if you want to label it that way, that's fine. We don't write final answers with mixed fractions, but if you think of it that way, that's certainly okay. So you can label that -1, -2 and 1/4 if you want. Then the directrix is at y equals -7/4, so that's -1 3/4. So about right here. And again, it's helpful if you remember where it was. So again, if you think better in mixed fractions, then write it that way, -1 3/4. So when I look at those, again, I'm trying to show that the distance from this point to the focus is the same as the distance from that point to the directrix. And in class, we did a bunch of these distance formulas. And we said that anytime the distance that you're looking for is vertical or horizontal, you can simply count. So if I'm trying to count from here to here, I went up a full unit and then a little bit more. Now, how much more you should know, because this was at -1 3/4. So to get to -2, there was only a 1/4 left. So that means that this distance right here is 1 1/4, which when we write it as a improper fraction, that means that the distance to the directrix is 5/4. And again, we got that because we counted, because it's a vertical line. And you can count anytime it's vertical or it's horizontal. Now, for the distance to the focus, which is this distance right here, that's a diagonal distance. That one we're going to have to do the distance formula in order to find it. So remember, we label our first point x1, y1. We label our second point x2, y2. Again, I don't care if you write it as a mixed fraction in between. As long as your final answer is in simplest form, that's no big deal. So distance to the focus. The distance formula, remember we put a big star by it in the margin where it was in the math tip in section 10.1. It's x2 minus x1 squared plus y2 minus y1 quantity squared. So to do the distance then, I am going to take x2, which is -1, minus -2, minus negatives become pluses, squared, plus y2, which is -2 1/4, minus -3, so that's also a plus, squared. So -1 plus 2 is 1, 1 squared is 1. So that's easy enough. -2 1/4 plus 3 is a positive 3/4. So 3/4 is what I get when I do this addition. When I square that, remember, we just square the top and square the bottom. So I end up with 9/16. So you can use your calculator to help you square that as long as you put it in parentheses first. You can also use your calculator to add these if you want. Just make sure you turn it back into a fraction at the end. This gives you the square root of 25/4, which the square root of 25 is 5. The square root, oops, I even wrote it wrong. I was thinking ahead to the next step. Silly me. The denominator was 16 over here, not 4. The square root of 16, however, is 4. So now we have just shown that the distance from that point to the focus is 5/4. We counted and showed that the distance to the directrix is 5/4. So we are done with number 2. We have shown that those distances are the same. Next, some people had a question on number 4, where we were looking at this equation. Remember that anytime we're trying to do focus, directrix, all of those, we are using these two basic equations. Y equals 1/4p x minus h squared plus k, or for horizontally opening, 1/4p y minus k squared plus h. Remember that this looks just like vertex form. We can see the vertex by the coordinates that are here. The reason why I write my a value as 1/4p is because remember, p is important. P is the distance from the vertex to the directrix. So what I'm doing here, the vertex is easy enough to find. If I look at A, my vertex, this is x, so this is the x coordinate with the sign change, so +4. The y coordinate then would be +3. Part B asked me for the focus. You kind of need to do actually the last one first before you can find the focus, and that is you need to know which direction this opens. So I look at it, I say, well, the y is alone, which means it's vertically opening, and it's positive, which means it opens up. We need that to find the focus because remember that the focus is always inside the parabola. So if I'm doing a little sketch here, at 4,3 is my vertex, I need to find P because I can simply count up in the direction of the opening to find my focus and then count down in the opposite direction to find my directrix. Now, P is going to come from this equation. 1/8 is the number in front. Here, that is 1/4p. So all you're doing is asking yourself, what does P have to be in order for me to end up with an 8 down here? And the answer to that is that P has to be 2 because 4 times 2 is what would give me my 8 in front there. So now that I know P is 2, I can go up 2 units to find my focus. Here was my vertex. I can go down 2 units, and that's where my directrix should be, which allows me to answer the next 2 questions. B, the focus, where is it? Well, it's right 4, and it's up 5, so 4, 5 are its coordinates. Where did I draw my directrix? Well, it's a horizontal line, so that means it's y equals, and what does y equal there? Y equals 1. So that's my directrix equation. Then the only thing left on that number is D, which is the axis of symmetry. Remember that the axis of symmetry always is perpendicular to the directrix, and it goes through the focus and the vertex. So right here in blue is where my axis of symmetry should be. And the equation of that line, since it's vertical, is x equals, and at those points, x equals 4. So there we have number 4 done. Now, 8 and 9 are very, very similar to each other and to number 4, even though you're given different information. Remember that the key is you have to know the value of P, and you have to know the location of the vertex. So I'm just going to do number 9, because again, if you follow the same information, you should be able to do 8. So the vertex on number 9 is at 2, 2. The focus is at 1, 2. And it tells us that the axis of symmetry is y equals 2. In class, I said you need to do a sketch because that's how you're going to be able to answer these questions. So, vertex 2, 2, here it is. Focus 1, 2. There that is. Axis of symmetry, y equals 2. So that means that because my focus has to be on the inside of the parabola, there's only one way that this can open. For the focus to be inside, it needs to open to the left. And that's one of the major pieces of information when we finish section 10.1. And if you look back in your Springboard book at the examples we did on number 21, the 2 or 3 of those that we did together, that's what we said you have to find. You have to find which way it opens, you have to find the vertex, which I know, and you have to find the value of P. Really important, that value of P. The value of P, remember, is the distance between the vertex and the focus. So, in this case, the distance between these two is 1. So it opens left, and P is 1. My vertex is at 2, 2. So now I'm ready to plug it in. So here are the 2 choices for your equations. I know that if it opens to the left, that it has to be the x equals, and also that my coefficient needs to be negative. So I'm going to write x equals negative 1 over 4 p. P is 1, so I plug that in. Then it's y minus k squared, so y minus the y coordinate of the vertex, which is 2, squared, plus h. If the y coordinate was on the inside, that means the x coordinate's on the outside, and it keeps its sign, so plus 2. So the only thing that needs changed for my final answer is that I need to simplify my 4 times 1. So I get negative 1/4 y minus 2 squared plus 2. And so there is my final equation. 13 and 14. Here you are taking the values that they gave you, negative 3, 0, negative 2, negative 3, and 2, 5, and you are plugging them into that standard form equation, y equals ax squared plus bx plus c. So my first one, plug 0 in for y, plug negative 3 in for x, and I get, because this gives me 9a, I get minus 3b plus c equals 0. When I plug in negative 2, negative 3, that means it's going to be equal to negative 3 because the y always goes over there. Over here, I'm always going to square the x, so negative 2 squared is 4, so that gives me 4a, and then multiply this, so minus 2b. C is always plain because there's nothing to plug in next to it. The third point, you should be plugging in 5 for your y, so that goes here, and then square your 2, so 4a, and then plus 2b in this case because it's a positive 2, so b times x would be 2b. So this right here is your system of equations that you have to solve in order to get the answer. Highly suggest that if you are solving this by elimination that you choose to eliminate c every time because the c's are always 1s. So it's very easy to multiply by 1 and negative 1. So I would very highly suggest that if you're eliminating that you are doing the C first. I'm not going to go through all of the steps of solving a 3 by 3. There's a whole separate video posted on that if you need help with solving 3 by 3s. But this was the part that was new, which was solving or setting up that 3 by 3. So if you can set up that 3 by 3, then you are golden there. Just to point out, you could use the quadratic regression to check your answer. So if you do your 3x3 solving and you're not sure if the answer's right, remember that these 3 points, if you plug into your L1, the x values, so -3, -2, and 2, and you plug into your L2, 0, -3, and 5, and you perform a quadratic regression on that, it's going to give you the equation. So that's just kind of a tool to check your answer, which could be very helpful. All right, so after we did that in section 10.2, we moved on to section 10.3, which was performing all of those very lovely regressions in our calculator and using them to answer some questions. I am going to show you my graphs for these. However, it takes forever on the computer graphing calculator to enter things. I think you saw that when you were waiting for me to enter all my data in the lists. So I am going to type in to my calculator the rounded versions that I came up with when I did it on my real calculator. So because of that, the answers that I'm going to get here are going to be a little different than what's on the answer key and what you probably got, because again, when your calculator pastes the equation, it doesn't round it. It uses all of the decimal places. So I'm not going to go through number 23 because you should be able to get the regression equations. Just remember that it said quadratic regression. So if you were getting something very, very off, maybe you were accidentally performing linear regression. Remember that it's quadratic regression that we're using here. So here, if we're looking at the picture of the calculator, just to remind you, you enter the data under Stat Edit right here, and this is old data again, not what I'm using right now, but you entered list 1, list 2, list 3, your data. Then when you went to perform the quadratic regressions, you'd go Stat, Calc, and then choose choice 5 to do quadratic regression. Now, a key, if you want both of these quadratics in there at the same time, you paste the first one in your Y1. But when you go to do the second quadratic regression, don't forget to change your list, because for the truck values, your X list is still L1, but your Y list is L3, and you would want to paste that into your Y2. So just please be thinking about what you're pressing into the calculator. Don't just mindlessly do the exact same thing we did in class. Think. If it says X list, make sure you're using the list that you actually want to be your X's, that you're using the list you actually want to be your Y's. So again, I am just going to type into my screen the answer that you get when you perform the regression. So 0.047x squared plus 2.207x plus 0.214. So that was the quadratic equation that the regression gives you for the car. That should be in your Y1. Again, yours won't be rounded, so yours will be better, and your answer should give you what I have on the answer sheet. For the truck, it was 0.064x squared. Then it was plus 2.210x, and then it was a minus 0.500. So those were my equations that you should have the non-rounded versions for in your calculator. Again, I'm not going to enter the data, so I don't have my plot on because I don't want the scatter plot. I'm just looking at the quadratics themselves. Because when I graph it, and I may have to adjust my window, remember your window has to match what you're looking for. In number 24, it asks you to find how much further it's going to take the truck to stop than the car. So it's asking you to plug 50 miles per hour in for your X. So if we want to do that, we need a window that's appropriate. So we need our X max to go up to at least 50. Now later, it asks for 60 miles per hour, so I'm just going to go ahead and make my X max 65 because that gives me more than enough. And then if I adjust that, hopefully I can see a good version of my parabolas. So in blue is the car data. In red is the truck data. Notice that at first they look exactly the same and then the gap starts to get bigger as we go. But you could, of course, solve 24 by plugging it in by hand, plugging in 50 for x in both of those equations and then subtracting. In your calculator, remember we do second trace value, so choice 1, and we plug in 50 and we press enter. So on the car data, again, this answer is just very slightly off from what I did myself because I rounded it when I plugged it in. So here I got 228.064. Really, when you paste it, you get 228.429. And then I can scroll right up, just press my up button to get to my red and see that I get 270. So how I got my 41 more feet is that I took my 270, or in my case it was 269.5, and I subtracted the 228.43. So these two y values, the red one and the blue one, you subtract those to get the answer to 24. 25 says that it's for 60 miles per hour, and it wants to know that if the truck is, let's see how far away, I can't remember, 300 feet from the intersection, is it going to be able to stop in time? So that's just a value for 60, so I can just press in 60 instead of the 50. And see, make sure you're looking at the truck data, although in this case it doesn't matter because the car wouldn't be able to stop either. But the truck data is 362.5. Again, on the non-rounded version, it's 361.8-ish. So no, if it's only 300 feet from the intersection, it's not going to be able to stop in time. All right, so that takes you through all of activity 10. Then we are looking at activity 11, where we focused on vertex form as well as our transformations. So looking at a couple of these, on number 3, you had the equation and it wanted you to, based on the equation, so again, this is the start of activity 11, that's why I drew the line on the answer sheet. You have g of x equals x plus 2 squared plus 3. So I'm looking and I'm saying, okay, vertex form is f of x equals a times a b is there only if it's horizontal. So it looks like this. So what do I see here? I see a plus 2 on the inside with the x. So that means that I'm horizontally shifting left 2. This on the outside, my k, remember vertex is always located at h comma k. That means that there's a vertical shift up 3. There is no number in front, so there is no reflection. There is no vertical stretch or shrink, and because there's no number inside here, that means there's no vertical stretch or shrink either. So all I'm doing is moving left 2 and up 3. Number 6 wants us to do the same thing, only starting from the graph. So it's very, very important that you know the parent graph t-chart, at least half of it, because we know that its vertex is at 0, 0, but when x is 1, you should know y is 1. When x is 2, you should know y is 4. When x is 3, you should know y is 9, 4, 16, 5, 25, because again, the parent graph is y equals x squared. So however many you go to the right, you should square that to get how many you would go up. That's really important for figuring out width on the parent. Number 6, if you look at the graph that it gave you in your book, and I'll try to do a rough sketch of what they gave you here, you needed to locate the vertex first. So when you look and find the location of the vertex, you can label it. It's at -3 and -2. So if the vertex is at -3, -2, that's telling you the values of h and the values of k. Remember that we changed the sign for the h when we put it in the equation. So that means when I'm looking up here, I'm going to do x plus 3 squared. The k keeps its sign, so I'm going to do a -2 for the y-coordinate of the vertex. And then to look to see if I need anything in front, all I need to do is look at the width. So I look at the graph that I'm given. Normally on the parent graph, I would go right 1 and up 1. I went right 1, up 1. Then I would go right 2, up 4. The other 2 points on the graph are right 2 and up 4. So the graph that they gave you is the same width as the parent, which means that your A value is 1, which is why there's no number in front there. So it's just h of x equals x plus 3 squared minus 2. All right, next one that I want to look at is, let's see, which one was harder? Let's look at number 18, because this one had a lot of steps in 18. 14 is the same type of problem, but there's no shifting, so that makes it a little bit easier. So in 18, they gave us the equation, so backward of the one that we just did. So they gave us this equation. They asked us to describe all the transformations that we see and then to actually graph it. So again, you have to know that when we are looking at this, you need to know what things control. So this is the x-coordinate of the vertex. Remember that the sign changes. This is the y-coordinate. The sign stays the same as whatever that is. A controls 2 different things. It controls vertical, stretch or shrink, and we just kind of draw a line up here. We say if it's negative, there's a reflection, meaning it's going to open down because there's a reflection in the x-axis. So when I look at all of those things, I know this like the back of my hand. I look over here and I say, okay, x-coordinate of the vertex, change the sign, which means the vertex is going to be at -2, and then this one keeps its sign, -5. So when I write that as a transformation, I say that I'm going to do a horizontal shift, left 2. I'm going to do a vertical shift, down 5. Then I need to look at the rest. I have a negative. If negative, that means it's a reflection in the x-axis, so that's what I wrote. Reflection in the x-axis. Then this, the 3, represents a vertical stretch by factor 3. Remember that if this number is bigger than 1, and again, we're ignoring the sign. We're not looking at the negative. We're just looking at the number itself. If it's bigger than 1, then it's a stretch. If it's between 0 and 1, then it's a shrink. So here are all my transformations. Now I need to make sure I know how that applies to my actual graph. So when I go to graph this, I'm cheating here because I'm working ahead in my brain to know which way this opens and where the vertex is. So that's the part of the coordinate plane that I'm drawing. So when I'm drawing this, again, we already said where my vertex is. My vertex is at -2, -5. So I can plot that much. There's my vertex, -2, -5. Then I know because of the reflection that that means it's going to open down. So when I go to plot my other points, I need to do so in a downward direction. So the key is normally on the parent, I would go, if we look at our little key here, I would go right 1 and up 1. Well, first of all, I'm moving down since it's reflected, but instead of going right 1, down 1, this factor 3 means I need to multiply how much I go down by 3. So I'm going to go right 1 and down 3. So I do that, right 1, down 1, 2, 3. So this point is at -1, -8. Then I also go left 1, down 3, so that I have its symmetric point, which is at -3, -8. Now, if I were going to plot my 4th and 5th points, again, normally I would go right 2 and up 4. I'm going to go down, but I'm going to multiply it by 3. So I would go right 2 and down 12. So right 2 would go over to my axis. Unfortunately, I don't have quite enough room to go down 12. I could go down 2, 4, 6, 8, but that's not quite enough. So remember that we did the ones in class. When it goes off the graph, then sometimes it's okay to only have 3. If they fit, they have to be there, but if they don't, then sometimes we settle for 3 points instead of 5. But if the 5 will fit, they have to be on there. All right, next, I wanted to do 19 because it's the only one on here where it talks about the horizontal. So again, I talked about the horizontal up here. B horizontal shrinks and stretches go inside the parenthesis generally, and we usually only look at them when we don't have a shift. So it said to write the equation when you had a horizontal shrink by factor 1/4. So the key here to remember, first of all, is that it needs to go on the inside. So g of x equals, you know the x is going to be there, you know it's going to be squared. The number that goes in here has to be the reciprocal of the factor. So don't put 1/4 in there. It's 4 over 1, which is just 4. So when you're doing a horizontal shrink, it goes in the parentheses, and it's always the reciprocal of the factor. So for instance, if I had given you, let's say, this equation and asked you to describe the transformation, and let's just even say that I did this, if I had h of x equals this, describing the transformation, I would say, first of all, it has a vertical shift up 3. The negative means it has a reflection in the x-axis. This 6 means that that is a horizontal. When they're big numbers, bigger than 1, that makes it a shrink. In this case, by factor 1/6. So make sure when you see this that you do the reciprocal there. Likewise, if the equation had been 1/2 x inside the parentheses, this transformation would be a horizontal stretch because 1/2 is between 0 and 1 by a factor of 2 over 1. So by a factor of 2. So just make sure that you review what we did in class for those. All right. We've already done some of the plotting ones, so last thing I want to do is to remind you how to put it into vertex form by completing the square. So I am going to look at, let's see, let's do number 28 first. So number 28 was g of x equals 3x squared plus 6x plus 1. So first thing I did when I completed the square, and remember we had the 2-column piece of paper that we filled out for our example, we replaced the g of x with a 0. We move our constant over to the other side, so subtract the 1, so we've got -1 over there now. And then we just flip-flop sides so that the constant's on the right. So 3x squared plus 6x equals -1 is what I have after that step. Once I have it in that format, so ax squared plus bx equals c, then I need to factor out the coefficient on the left side. Remember, this is not a guessing game. Whatever the number is in front, that's what you factor out. So I factor out a 3. Remember, it's reverse distributing. 6 divided by 3 is 2. So if I redistribute this 3, it would give me back 3x squared plus 6x. So I know that that is right. I'm going to add some blanks so that I can complete the square. On the left side, we complete the square with b divided by 2 squared. So b is 2. 2 divided by 2 is 1. 1 squared is 1. Once I've completed the square on the left, then I have to do my swoop multiplying to complete the square on the right. So 3 times 1 is 3. And now, on the left side, this guy right here needs factored as a PST. Remember, this is not a guessing game of factoring. Square root the front to get the front. Sine of the middle goes in the middle. Square root the back to get the back. And then put a squared on the end. On the right side, combine your like terms. -1 plus 3 is 2. And so now, to get it back into vertex form, again, vertex form looks like this guy right here. So I need to move my y coordinate back over. So I'm going to subtract the 2. So I get 3x plus 1 squared minus 2. And then my last thing is I need to put my function notation back in. So I put back in my g of x. And so there is my vertex form equation. Again, we've already gone over how to graph them. So from this point, you would describe the transformations that are on your key, and then you would plot the vertex at -1, -2. Because there's a vertical stretch, you would adjust the other points accordingly. All right, last one, I do want to look at number 33. Because it has a fraction, and that scares some of you. Now, you are allowed to use the decimal in this case because it's a real-life situation. However, you can't round it. If you round the decimal, you're not going to get the right answer. So I used a fraction because of that. But if you want to write out long decimals, have at it. In this case, since it's a real-life situation, that's okay with me. So your original was h of t equals -16t squared plus 22t plus 4. So we start off the exact same way that we did over here. And I'm going to replace this with a 0. I'm going to move the 4 to the other side by subtracting. So I end up with -16t squared plus 22t equals -4. So now, again, it's not a guessing game. Whatever this number is, that's what you factor out. So -16 t squared. Remember, it's reverse distributing. So I know it's going to be a minus because a negative times a negative gives me a positive. But in order to give me back 22, I'm really just doing 22 divided by 16. Well, 22 divided by 16 doesn't come out evenly. Again, you can use the decimal if you want to write them all out. I would prefer just to reduce that fraction. They're both divisible by 2. So I made that 11/8 t. So once I've done that, double check it, redistribute, Make sure that negative 16 times negative 11/8 does give you 22, which it does, as long as you remember to use the parentheses around your fraction. So now I can add my blanks on both sides. Hasn't changed for how we complete the square here. What I need to do is I need to take b and divide it by 2, but remember, dividing by 2 when we're dealing with fractions is really just multiplying by 1/2. So 1 times 11 is 11, 2 times 8 is 16. So b divided by 2 is negative 11/16 squared. Square the top, 121. Square the bottom, 256, and that's what completes the square on the left side. Don't fill that in on the right. We have to do our swoopy multiplying. You can use your calculator to help you if you want. Remember that math choice 1 converts things back to fractions for you. So this will tell you that this should be negative 121 over 16. So factor my left side as a PST. Square root of t squared is t. The middle sign is minus, so this is a minus. Square root of 121 is 11. Square root of 256 is 16. Slap a squared on it. Then again, if you want to use your calculator to help you add the fractions, you can. Just use your fraction button to convert it back. So that gives me negative 185 over 16. So now the only thing left to do is to move this back over by adding it. So I get negative 16 t minus 11/16 squared plus 185 over 16 is what my h of t would look like in vertex form. That's important because it asks you for what the maximum height is. The parabola looks like this. The maximum height is the y-coordinate of the vertex. So that's why we needed it in vertex form. So I could look here and say about 12 because 185 over 16 is about 12. Then to figure out the time for part C, that's just the x-coordinate. So the x-coordinate was 11/16, which is how I got the 0.7 seconds. Please, please, please make sure that you know what vertex form looks like. Make sure when you're looking at that form for finding focus and directrix that you know these. You know which one opens which way. Very, very important that you know that information. That is it. Happy studying.